In November 2023, Voyager 1, 24 billion kilometers from Earth, stopped sending usable data and began transmitting a repeating stream of ones and zeros instead. NASA spent 5 months diagnosing it. They found a corrupted chip. They fixed the transmission, but what caused the chip to fail? Something in deep space. They don't know what. That's the mildest entry on this list. After 47 years and 2 spacecraft, NASA has discovered that the region of space outside our solar system is far weirder, hotter, louder, and more structured than any model predicted, and the answers keep getting stranger. These are 10 things Voyager found in deep space that NASA has no explanation for. Let's get into it. In November 2023, something happened to Voyager 1. The spacecraft, which had been transmitting usable science data continuously since 1997, suddenly began sending back a repeating stream of ones and zeros instead of actual information. NASA engineers at JPL spent 5 months diagnosing the problem from 24 billion kilometers away, where a signal takes 22.5 hours one way to arrive. What they eventually found was a single corrupted chip inside the flight data system had overwritten part of its own memory and was looping the same pattern on repeat. They worked around it, relocating the corrupted code like rerouting traffic around a blocked road, and it worked. By April 2024, Voyager 1 was transmitting science data again. Here is the part that doesn't have an answer. What caused the chip to fail? NASA confirmed 2 possibilities. Either the chip was hit by an energetic particle from deep space, or it simply wore out after 46 years. They don't know which. Something in interstellar space may have physically struck the spacecraft's hardware. They cannot confirm if that happened or not. Around 2010, approximately 2 years before Voyager 1 officially crossed into interstellar space, it entered a region that NASA described publicly as bizarre and unexpected. The solar wind, which blows continuously outward from the sun at hundreds of thousands of miles per hour and fills the entire solar system, has stopped. Not slowed, stopped. In a region that still had the sun's magnetic field orientation, with none of the markers of interstellar space, there was simply no solar wind. Scientists called it the stagnation region. They hadn't predicted that it existed. The models said the wind would slow gradually and then end at the heliopause. What Voyager found was a windless zone sitting inside the boundary, a pocket of stillness in the middle of a region that should have had wind. NASA called it a new region of the solar system. The mechanism that produces a completely wind-free zone on the solar side of the boundary is still not fully explained. In 2012, as Voyager 1 was approaching the heliopause, it entered another region nobody had predicted. A magnetic highway where charged particles from inside the solar system and from interstellar space were streaming simultaneously along magnetic field lines. Solar particles rushing out, galactic particles rushing in, same path, same moment. Scientists at JPL called it a new region that represented a third distinct zone between the inner solar system and true interstellar space. What makes it strange isn't just that it existed, it's that the models had described a 2-zone system, solar system and interstellar space, separated by a boundary. Voyager found 3 zones. When Voyager 2 crossed the heliopause in November 2018, it found something Voyager 1 had not reported 6 years earlier. The boundary was leaking. Both ways. Solar particles were escaping outward into interstellar space. Interstellar particles were penetrating inward. National Geographic covered this in their November 2019 report. The heliopause, described as the hard boundary separating the solar system from everything outside it, was permeable. JPL's own press release said, "If the heliosphere is like a ship sailing through interstellar space, it appears the hull is somewhat leaky." What's stranger is that Voyager 1 crossed the heliopause in 2012 in a completely different direction and did not report the same bidirectional leakage. The same boundary in 2 different locations in space behaved differently. Voyager 1 crossed the heliopause at approximately 121 astronomical units from the sun. Voyager 2 crossed at approximately 119 astronomical units. Almost identical distance, but traveling in a completely different direction. Scientists expected the boundary to be roughly symmetric. What they found is that Voyager 2 encountered a thinner, simpler heliopause, stronger interstellar magnetic fields than Voyager 1 had measured. and an additional boundary layer just beyond the heliopause that Voyager 1 hadn't detected at all, a previously unknown region of space sitting just outside the solar system that only appeared in one direction and not the other. Scientists published 5 separate papers on Voyager 2's crossing simultaneously in Nature Astronomy in November 2019. The consistent conclusion across all 5 is that 2 separate crossings are so different from each other that no single existing model of the heliosphere fully explains both. At the heliopause, Voyager encountered something the models had not fully accounted for: a wall of extraordinarily hot plasma. The heliosheath, a turbulent outer region just inside the solar system's boundary, registered temperatures in measurements running between 30,000 degrees Fahrenheit and 90,000 degrees Fahrenheit. Some analysis put specific regions higher. The plasma in this zone was far hotter than the solar wind models predicted it should be. NASA's own reporting described the temperatures as surprisingly high, the mechanism generating that level of heat at the absolute edge of our solar system, far from any significant energy source, in a region where everything should theoretically be cooling down, has not been confirmed. Researchers have proposed compression heating, magnetic reconnection events, and charge exchange processes as potential explanations. None of them have been confirmed as the primary source. The wall is real, the heat is documented, why it's that hot is still being worked on. In August 2012, as confirmed by a July 2026 analysis reported on Space Daily, Voyager 1 recorded a sudden surge in galactic cosmic rays while the surrounding magnetic field barely changed direction. That's an unexpected combination. The 2 measurements, particles and magnetic field, should correlate, but they didn't. Scientists used this discrepancy to debate for nearly 3 years whether Voyager had actually crossed into interstellar space at all, or whether it was in some new, undefined region. The magnetic field eventually rotated, but the question of why the particle surge and the field change were decoupled in time, why they didn't happen together as predicted, never received a fully satisfying answer. In May 2021, Cornell University published a paper in Nature Astronomy that confirmed something Voyager 1 had been detecting continuously since 2017. Not a burst, not an event, a constant, persistent, narrow-band drone of plasma wave emissions in interstellar space at approximately 3 kilohertz. The paper, cited 54 times in academic literature, described it as quasi-monochromatic, almost perfectly single frequency. It persisted through region after region of empty interstellar space with no detectable triggering source. The hum predates solar events, continues after them, and doesn't correlate with any known external stimulus. Cornell's lead researcher described it as evidence that the interstellar medium has a low level of continuous activity. Essentially, that something in the space between stars is constantly vibrating at the same frequency. Since crossing into interstellar space in 2012, Voyager 1 has been measuring the density of the plasma around it as it travels. According to NASA's JPL's own published analysis from May 2021, electron density around Voyager 1 began rising in 2013 and reached levels approximately 40 times higher by mid-2015. The density has continued rising steadily since. Here is why this is so strange. Interstellar space, by definition, is supposed to be relatively uniform. Voyager 1 isn't heading towards anything. There's no star, no nebula, no object in its direct path that would explain why the region it's moving through keeps getting denser. It is traveling through what should be empty space, and the plasma is consistently thickening around it. JPL's published analysis describes the rising density as making waves in the field, their words, and notes it is not consistent with uniform interstellar medium models. Voyager 1 is now 47 years old and 24 billion kilometers from Earth. It keeps moving, the density keeps rising, nobody has confirmed why. After the 47 years of Voyager missions, 2 spacecraft crossing into interstellar space in different directions, and decades of combined data, scientists still do not know the shape of the heliosphere. The heliosphere is the massive bubble of solar wind and magnetic field that surrounds our entire solar system and protects every planet, including Earth, from galactic cosmic radiation. We live inside of it.